Hi everyone, in this video I will talk you through a simple but exciting experiment that demonstrates how polymers and graphene oxides can be used in high voltage insulation applications. We will have 3 steps. Let's start with step 1, material preparation. Here you can see that we begin by dissolving a polymer in a solvent. Every polymer has a compatible solvent which we identify using standard chemical handbooks. So after fully dissolving the polymers in the solvent, we add graphene oxides, a highly conductive nanomaterial with remarkable surface area and unique electrical properties. So at first you can see in this video that we have 2 distinct liquid phases. This is because graphene oxide is hydrophilic and does not easily disperse in all solvent. To solve this, actually the graphene oxides in the oil, we introduce a polymeric surfactant or compatibilizer, which helps stabilize the dispersion into a single-phase mixture. So the final solutions, you can see that it becomes visually shiny and uniform, which indicating a stable composite mixture. So we will start with second 2, morphology analysis. Here we use the optical microscope to see the microstructure. You can see that graphene oxides has a flat and transparent sheet resembling flakes, which are the graphene oxide layers. But after adding the oil and polymer, the microstructure changes noticeably. We see uniform dispersion of geo and the formation of small microbubbles or droplet-like structures. These are the result of the interaction between the surfactant polymer chains and graphene oxide sheets. So these bubbles may trap air or form a porous structure, which can significantly affect the dielectric performance of the material, which sometimes positively reducing dielectric loss or increasing breakdown strength. So this change in morphology shows how nanomaterials interact within a polymer matrix, an important factor for tailoring insulation materials. Now we continue with step 3, which is high voltage test. Now comes to high voltage experiment. We subject our polymer graphene oxide geo sample to a gradually increasing electric field using a high voltage DC or AC power supply. The goal is to evaluate its dielectric strength and the maximum voltage the material can withstand without breaking down. So during this test, we monitor partial discharge behavior, electric field distribution, and any visible degradation like electrical tring or corona discharge. If the composite shows a higher breakdown voltage than pure polymer, it means graphene oxide has enhanced its insulating ability, likely due to barrier effects or charge trapping properties. The microbubbles or nanostructures seen earlier may also play a role by disrupting charge pathways, improving the material's resistance to electrical failure. This kind of research helps the designing next-generation insulation materials for COBs, capacitors, high-voltage equipment, and energy storage devices. So thanks for watching this video. If you enjoyed this experiment and want to see more real lab-like work involving polymers, nanomaterials, and high-voltage technology, don't forget to like, subscribe, and share this video. Feel free to ask your questions in the comments. I will be happy to explain more, and thank you so much.